All right, guys, got a video for you today about graphene quadratic functions. And so we have our standard form here, which is f of x equals ax squared plus bx plus c. Of course, the x squared terms are quadratic term, and the c is our constant term. And then it says also that the graph of any quadratic is called a parabola, which we know. That's that U shape if it's facing up, or the N shape if it's facing down. Okay, a couple things to consider here is that all parabolas have an axis of symmetry, and that's going to be our next part, which is x equals negative b over 2a. That's how you find the axis of symmetry, of course, with our a, b, and c's being the different terms of our quadratic. Next, it says that the point at which an axis of symmetry intersects parabola is called the vertex. Okay, so it's going to be at the very bottom or the very top, depending on which way the vertex, or sorry, which way the parabola is facing or opening. And to determine that is if our a value is greater than 0, or I'm going to say if it's positive, then the parabola is going to open up. Okay, so in this example, our a would be positive. And if the a is less than 0, if it's negative, then the parabola opens down, like in this one I just put the rectangle around. Okay, lastly, on this slide, it says that the y-intercept can be found by finding f of 0. And look at what happens when you do that. 0 squared is 0, and so 0 times a then is just going to be 0. b times 0 is 0, so you end up with 0 plus c, or just c. You can say f of 0 equals c, your constant term. So that's a nice way to find the y-intercept. So for example, if c ended up being 4, then you can do f of 0. Well, this is an input. An input, of course, is our x value, and the output that you get is the y value. So 0, 4 in this case would be the y-intercept. So we'll have to keep that in mind as we try a few of these. Let's try one here, which says, without graphing, determine if the parabola will open up or down. Then locate the axis of symmetry and vertex of the parabola defined by, and then here's our quadratic equation, f of x equals negative 3x squared plus 6x plus 1. Okay, so first off, what is the DOO? The direction of opening is what that stands for, direction of opening. Our choices are either up or down. And of course, since our A is negative, this is going to open down. Okay, secondly, the AOS, the axis of symmetry. Remember, that's defined by x equals negative b over 2a. All right, so if I fill those in with mine, well, my b is 6, so negative, still looks like negative b, negative 6 over, and then 2 times a, 2 times negative 3 would also give me a negative 6. So negative 6 over negative 6 is just 1. And that's x, if you think back to the beginning, x equals 1. Okay, then you use, to find the vertex, you use that x equals 1. Since the vertex has to be on that line, on the axis of symmetry, that's going to be our input. So what we're going to do is we're going to take this quadratic equation. Instead of doing f of x, we're going to find f of 1, the number that I just found for the axis of symmetry. And when I plug that in, we're going to see what it spits out for the y value. So as I do this, let me fill this in with blanks. It's going to be negative 3. And then I'm going to fill in a blank here. So blank squared plus 6 times blank, blanks wherever the x's are, plus 1. And then in those blank spots, we're going to put a 1. 1 squared is 1. 1 times negative 3 is negative 3. Make that a little better. Plus 6 times 1 is 6, plus 1. Negative 3 plus 6 is positive 3. Positive 3 plus 1 is 4. Okay, again, the x value that we used there was 1, and the y value that spat out at us is a 4. So 1, 4 is going to be the vertex of this quadratic equation. Very similar this time, except now we're going to be graphing. This one says, what is the direction of opening? And here our a value. You could think of, if there's no number there, you can think of it as a 1, a positive 1. So that's going to be opening up since it is positive. The axis of symmetry, again, is x equals negative b over 2a. So our b is currently negative 6, so negative 6 is positive 6 over 2 times, and a here is 1, so 2 times 1. 6 over 2 equals 3. X equals 3 is going to be our axis of symmetry, which that is the line, use a dotted line right here. That's this line. So it's going to be symmetric over that line. Okay, the vertex then, just like last slide, we're going to plug in, instead of f of x, we're going to do f of 3, since it has to be on that line of x equals 3. So f of 3, again, I'll leave blanks, blank squared minus 6 blank plus 9, and inside those blanks, we're going to put a 3. 3 squared is 9. Try to write this small so I have room here. 9 minus 6 times 3 is 18. Plus 9. Well, 9 minus 18 is negative 9. Negative 9 plus 9 is 0. 0. So the vertex is actually, I'll write it here, it's actually going to be the x value of 3 that we used from up above, and the y value that's spat out at us is 0. So 3, 0 on the graph, I'll use red, is right here. Okay, that's our vertex. And then the y-intercept, if you remember from a couple slides ago, that's just going to be the c value, because it's where we plug in 0 for x, and then when you do that, 0 minus 0 plus 9, in this case, would just give us a 9. All right, so 0, 9 is the y-intercept, and of course that's where it crosses our y-axis. So this is going to be up here at 0, 9. And then a little trick is that this is currently 3 spaces away from my axis of symmetry. So 3 spaces in the other direction, 1, 2, 3, it would also hit perfectly on the grid right there. Okay, that's just a little trick you can remember as you graph these. So I'm going to try to graph mine, making that U shape coming up like this. Again, mine's not going to be perfect, but you get the idea. Okay, and then one of the harder parts is to find the domain, range, and then the intervals of increasing, interval of decreasing. So domain and range we've talked about before. That's going to be domain, our x values, range, our y values. So if you think of all the x's kind of spanning our x-axis here, if I were to kind of zoom out and look at this parabola, it's going to start actually at negative infinity. It would go on forever to the left, and it would go to positive infinity forever to the right. All right, and then our range, if I cross these off, our range is our y values. How far up or down does this go? You'll notice here that it actually starts way at the top at positive infinity, but it does not ever go past here, right? And that's going to be 0. So it's going to be, and the way we write this is from least to greatest. So it actually starts at 0 and it goes up to infinity. And since it's a hard spot at 0, it actually hits 0, that gets a bracket. Infinities never get brackets, they always get parentheses, so it would look like that. Okay, and then kind of made a mess over here. Give me a second to erase this. That was our vertex. Oops, right here. The trickiest part, I think, is the interval of increasing and the interval of decreasing. And the way I like to remember this is like I read a book from left to right. We're going to view this, whether it's increasing or decreasing, as to what it's doing from left to right. So for example, from left to right here, this is going down to start with, and then back up from left to right once we get to the bottom or to our vertex. Okay, so like I said, it's going down from positive infinity down to, and we read this using our x's, so from positive infinity down to 3, I'm sorry, negative infinity, that's the x values, negative infinity to 3, that's when it's decreasing, okay? And at 3 itself, it's flat, so it's neither increasing or decreasing, so because of that, it also gets a parentheses. At 3 itself, it is flat, it's 0. This is increasing then from 3 to positive infinity. Again, we're reviewing this in terms of the x values. So from 3 to this one's the positive infinity. Again, they both get parentheses. So again, that's a little bit tricky to figure out, but maybe with the next one we do, you'll be able to think about it better. All right, speaking of the next one, here it is. This is example 3. It says graph f of x equals 2x squared plus x plus 1 by determining the following. So first off, the direction of opening Again, this one's going up. It's going up because our A value is positive. The axis of symmetry, this is x equals negative b over 2a. Negative b in our case is negative 1 because our b value is 1. Over, and then 2a, 2 times 2, is actually negative 1/4. So kind of an ugly looking fraction, but that is what the axis of symmetry is negative 1/4. So it's going to be really close right there, almost. Wasn't too bad. I'll leave it like that so you can kind of tell just a little bit to the left of our y-axis. Okay, the vertex then is going to be our quadratic equation, but instead of f of x, we're going to do f of negative 1/4. And when I input those, let's see what happens. This is 2 times negative 1/4 squared plus negative 1/4 plus 1. Okay, so this is going to turn out maybe a little bit interesting, but we can work through the fractions. Negative 1/4 squared is positive 1/16. And 2 times positive 1/16 is 2/16, or that would simplify to be 1/8. So I'm going to replace this with 1/8. Plus a negative 1/4 is minus 1/4 plus 1. So if I can change these all to have common denominators of 8, maybe, notice 1 currently is 1 over 1. Let's see what that would look like. So the 1/8 stays 1/8. Negative 1/4 as a fraction with a denominator of 8 would be negative 2/8. Let's multiply the top and the bottom by 2. And then 1 over 1, got to multiply everything by 8 on this one, would be plus 8 over 8. All right, so 1 on the top, my denominators are common, so they're going to stay 8 on the bottom. But on the top, 1 minus 2 is negative 1. Negative 1 plus 8 is 7. So we get 7/8 here for the output of the vertex, where the input was negative 1/4. So we want to write this vertex as a point, an ordered pair, which is negative 1/4 for the x and 7/8 for the y value. Okay, again, it's going to be really hard to graph, but just kind of maybe listen to how I say this, because I probably won't mark it up too accurately. Negative 1/4 on that blue line, a little bit to the left of my origin. And then 7/8 is going to be almost up here. Not quite to 1, but a little bit below it. So I think you can kind of get the idea with that red dot there. Okay, the y-intercept. The y-intercept on this one is when we plug in 0 for x. It's f of 0, actually. And like we said in the last slide, this is going to turn to 0, this is going to turn to 0, and we're just left with our c value, which is 1. So f of 0 does equal 1, and our input was 0, our output was 1. So at 0, 1, again, really close here, 0, 1 is going to be our y-axis, or y-intercept. And then if I would go 1/4 in the other direction, it'd be about right there. Again, guys, this is a little bit tough to see, but you can kind of get the idea. This is going to make a parabola, kind of like that, probably. Okay. The big idea is that you get all the numbers right, and then, again, I'm not too worried about how you graph it, as long as it's going in the right direction. In this case, it's going up. All right, the domain on this one, that's our x values. It would go forever in the left and forever to the right, so that's negative infinity to positive infinity. The range, well, here, you got to be a little bit careful. It starts at 7/8. That's the lowest. 7/8 is the lowest y value, and it does hit that, so we're going to have a bracket. And it goes all the way up to positive infinity. The interval of increasing, well, it's increasing from here on up, and that would be from, and this is just the x values that we're looking at, so it's going to be from negative 1/4 to positive infinity, and it's decreasing from negative infinity to negative 1/4, negative infinity to negative 1/4. Again, we write the intervals of increasing and decreasing. That's talking about the x values, okay? So the x values. So you could think from negative infinity, let me try to switch colors here, from negative infinity all the way to right here at negative 1/4, that is going down, okay? Going downhill, draw a better arrow. And then if I switch colors from negative 1/4 to positive infinity in the x direction, our graph is increasing. It's going uphill. And again, you want to read that from left to right. Oh, I did forget. Sorry, this should have a parentheses around that infinity. Okay. And then we have vertex form. Vertex form is next. This is very similar to the last one, but slightly different, where some people prefer this because it gives you the h and the k of the vertex, where it's x minus h on the inside plus k on the outside of our parentheses. Okay. The axis of symmetry is going to be x equals h there. And then if it opens up, a is going to be positive or greater than 0. Again, you can read that as positive. And it's opening down if a is less than 0. So that part stays the same. That part stays the same. Less than 0 means negative. And then our y-intercept, this time you will have to plug in f of 0 and see what the output is in order to determine the y-intercept. And that's going to be in the form 0, since we inputted, or our x value, we input a 0, and whatever the output is going to be that question mark. Maybe again 0.4, 0.3, whatever it ends up being. Okay. A couple of things to note is the parabola is shifted horizontally x units and vertically k units. And that's shifted from our origin. So let's try one. Here it says graph f of x equals negative times the quantity x minus 2 squared plus 4 by determining the direction of opening, axis of symmetry, and so on. So a couple things here is this is going to open down. It's going to open down because our a is almost like a -1 in front, right? And if it's negative, it opens down. The axis of symmetry, remember, if I go back to this slide here, the axis of symmetry is just going to be x equals h. X equals h. So in this case, x minus 2, well, that minus 2, the 2 is going to be along this line, x equals 2. And so that dotted line is going to be my axis of symmetry, which is just x equals 2. The vertex then is the hk. And if you remember, this is h and this is k. So it's going to be 2, 4. And I can plot that. I'm going to put that maybe in green. 2, 4, 2, 1, 2, 3, 4. It'll be right there is the vertex. And then the y-intercept, this part you do actually have to plug in f of 0. And so in this case, f of 0 is going to be negative times the quantity. And then remember, this is usually f of x, but we're plugging in 0. So I'm going to replace all the x's with 0. 0 minus 2, quantity squared plus 4. Make that a little better, plus 4. Well, 0 minus 2 is -2. If I do order of operations, parentheses first, -2 squared is positive 4. But the negative out front, it's like -1. -1 times that positive 4 is -4. And then at the end, I have plus 4. -4 plus 4 is 0. So when I plug in 0, I get 0. So the y-intercept is actually the point 0, 0. Which would make sense, okay? Because this is opening down. And so this side will look kind of like that. And then remember the trick I said earlier, this is currently 2 spots away from my axis of symmetry. So 2 spots away in the other direction would be right there. And then this side of the parabola would look something like that. Remember, those should be mirroring each other on either side of the axis of symmetry. Okay, looking at this, looking at the blue, the domain is our x values. So this goes forever to the left, which is -infinity, and forever to the right, positive infinity. Excuse me, the range for this one. This is going to start down at -infinity, and it's going to go all the way up until right here, which is 4, right? That's at 4. Let's erase those. So it's going to be from negative infinity, the lowest point, to the highest point, 4. Infinities we can never reach, so it's going to get parentheses. But this 4, there is a dot there. It is going to get a bracket. All right, and then this time, from left to right, this is increasing all along here. It's going up from left to right. And so that's going to be from negative infinity, and then it stops increasing at 2. So from negative infinity to 2, both of those get parentheses. And then it's decreasing this way. It's decreasing that way. And again, that's the x values of 2 all the way to positive infinity. So this is 2 to positive infinity, both with parentheses. All right, and I think that's it. So I'm not going to assign that homework right now. We're just going to put this video on the website. But if you have questions, send me an email. But I think this video should be able to help you out.